Find the amplitude, the period, and the horizontal shift of y equals 1 plus sine of 1 over 3 pi x plus pi, and graph one complete cycle. Before we answer these questions, we should put this in the factor form by factoring out 1 over 3 pi, which is the constant multiple in front of x. As of now, pi is not the horizontal shift. To factor out 1/3 pi, we would write y equals 1 plus sine, and then use an extra set of parentheses. Take out 1/3 pi only, open the parentheses. If it was 1/3 pi x and we factor out 1/3 pi, then we end up with x inside the parentheses. Plus, if it was pi and we factor out 1/3 pi, the pi and the pi canceled out, and so we end up with 1 over 3, which is 3, and so this is plus 3. Close the parentheses, and then close the parentheses. Make sure you double check this. 1/3 pi times x is 1/3 pi x, and 1/3 pi times 3 is pi. Once the equation is in this form, the coefficient in front of the trig expression is 1, and so the amplitude is 1. If it is negative, we would need to take the absolute value of it. The plus 3 in sign of sine indicates that this is the horizontal shift, and it's shifted to the left 3 units, and so the horizontal shift is -3. The period is always 2 pi over the coefficient in front of x, which is 1 over 3 pi. The pi and the pi canceled out. We end up with 2 over 1/3, but 2 divided by 1/3 is 6, and so the period is 6. Instead of using the transformation of sine to graph this function, we're going to use the 5-point techniques. To use the 5-point technique to graph this function, we will take the period, which has a distance of 6, but we would need to start at -3, which is the horizontal shift. Starting from the horizontal shift, we would have to go to the right a distance of 6 units to complete one cycle, because the period is 6. If we take -3 plus 6, we will end up with x equals 3. And then we always take the period and divide it by 4 for 4 intervals. And so each interval has a distance of 3 over 2, or 1.5. We take this length and divide it by into half, and then we divide it by into half again. And so from -3, we increase it by 3 over 2. -3 plus 3 over 2 is -6 over 2 plus 3 over 2, which is now -3 over 2. -3 over 2 plus 3 over 2 is 0. 0 plus 3 over 2 is 3 over 2. And 3 over 2 plus 3 over 2 is 6 over 2, which is 3. And so always divide by the distance or the period by 4 and add the length of each subinterval each time. These are the 5 x values that we will use to evaluate the function to end up with the 5 points. Once we have the 5 points, we will sketch the graph of the given function. If we follow this procedure, it is guaranteed that we end up with the 5 nice points. We will see. We will evaluate y equals 1 plus sine of 1/3 pi x plus 3 using these 5 numbers The first number is negative 3. The second number is negative 3 over 2. The third number is 0. And the fourth number is 3 over 2. And the last number is x equals 3. The goal is to obtain 5 points so that we can graph the function. These are the x-coordinate of the 5 points. The first, x equals negative 3, y is 1 plus sine of 1 over 3 pi. We plug in negative 3 for x. The plus 3 from the equation stays. And so what we're doing is that we rewrite the given function and we plugged in the x equals negative 3 only. The reason why it is nice is because, as we can see, negative 3 plus 3 is 0, and so 1/3 pi times 0 is 0. Sine of 0 is 0, so we end up with 1 plus 0, or 1. For x equals negative 3 over 2, we have y equals 1 plus sine of 1 over 3 pi, and then we plugged in negative 3 over 2 into x plus 3. This is 1 plus sine of 1/3 pi. Negative 3 over 2 plus 3 is negative 3 over 2 plus 6 over 2, which is 3 over 2. And the 3 and the 3 canceled out. We end up with 1 plus sine of pi over 2. But sine of pi over 2 is 1. And so 1 plus 1 is 2. For x equals 0, y is 1 plus sine of 1/3 pi. And we plugged in 0 plus 3. This is 1 plus sine of 1/3 pi times 0 plus 3 is 3. 3 canceled out, so we end up with 1 plus sine of pi, which is 1 plus 0, because sine of pi is 0. 1 plus 0 is 1. For x equals 3 over 2, y equals 1 plus sine of 1/3 pi. X is 3 over 2, and then we still need to add 3. The only thing we did here is substituting 3 over 2 into x. This is 1 plus sine of 1/3 pi. 2/3 plus 3 is 2/3 plus 6 over 2, which is 9 over 2. And so this is 1 plus sine of 1/3 pi times 9 divided by 3 is 3. And so inside of sine, it is now 3 pi over 2. And sine of 3 pi over 2 is negative 1. And so 1 plus negative 1 is 0. And lastly, y equals 1 plus sine of 1/3 pi. We're substituting 3 into x now, plus 3. This is 1 plus sine of 1/3 pi times 3 plus 3 is 6. And so this is 1 plus sine. 6 divided by 3 is 2. But sine of 2 pi is 0. So 1 plus 0 is 1. The 5 points we end up with are, the first one is when x equals negative 3, y is 1. The second point, x is negative 3 over 2, y is 2. The third point, when x equals 0, y is 1. The fourth point, when x is 3 over 2, y is 0. And the last point, when x equals 3, y equals 1. We then plot these 5 points in the xy plane. The trick is to divide the period starting at the horizontal shift into 4 equal pieces. And so we start at x equals negative 3, and then the increment is 3 halves, so the next x is negative 3 over 2, another 3 half is 0, and then 0 plus 3 half is 3 half, another 3 half is 3. When x equals negative 3, y is 1. And so The first point is at -3, 1. The second point is -3/2, 2. The third point is 0, 1. The fourth point is 3/2, 0. And the last point is 3, 1. We then connect these 5 points to form the graph of the given function. Keep in mind that this is the trigonometric graph, and so it should be curvy because it mimics the motion around the unit circle. This is the graph of the given function.